Hello and welcome back to the video lectures on inventory models. So we continue with the third model, and we have already seen the procedure for solving problems on this model in the previous video. So let's solve an example based on this model. So in the previous video, that was the procedure developed for solving examples on this model. So you can just pause the video and go through the procedure. So procedure is fairly simple, and you should be aware of this formula for determining Q dash, and only the thing is TCU1 is the formula that we developed in the very basic EOQ model. Okay, so let's take an example of loop car garage, and this garage uh, provides a service of replacing the oils in the vehicles. So let's look at the data of this garage. To replace the oils in the vehicles, this garage buys car oil at a bulk of $3 per gallon, and the supplier gives discount if the quantity is more than 1000 gallons, and this discounted price is $2.5. Okay, so that means $3 is C1 and $2.5 is C2, and small q, that threshold that I was talking about, or I have been talking about, is 1000 gallons. Then the garage services approximately 150 cars per day, and each oil change takes 1.25 gallons. Okay, so that means this is the data about the demand small t, and we need how much gallons of oils is required per day. So that will basically 150 cars per day into how much of gallons of oils is required. So this is simply 1.25 gallons. Okay, so this comes out to be about 187.5 something. We just calculate. So this is the demand of the oil that it requires, or this garage requires 187.5 gallons of oils per day. So that's the demand in D. Then this is the storage cost or holding cost. Lube car stores bulk oil at a cost of 0.02 per gallon per day. So this is small h, and the cost of placing an order is $20. So we have this fixed component K of the ordering cost. Okay. Finally, we have been asked to determine the optimal order quantity, and we want to determine how much the garage should order every time an order is placed. So this is the same data from the previous slide, and this C1 and C2 has been converted into the mathematical expression that we saw on one of the earliest videos on this model. Then this is the demand D, then holding cost small h, order cost, and the threshold small q. Okay, so you can just pause the video and just make sure that the data given here is correct. So let's step through the procedure that we saw in the previous video. Step 1 is to calculate this q star. To calculate q star using this formula that we saw in the very basic EOQ model, and this Q star comes out to be 612.37 gallons. You can just pause the video and do the calculations yourself. Okay. Then we want to know, based upon the Q star that we just calculated, whether the threshold Q lies in zone 1 or not. So we compare the Q and Q star. So Q is 1000 and Q star is 612.37. That means threshold is greater than Q star, and that means the threshold does not lie in zone 1. That means it should lie either in zone 2 or zone 3. So as small q is greater than Q star, we proceed to step 2, and then we find Q prime using this formula. So you can just substitute the values and find out Q prime. You can just pause the video and then you should get the value of Q prime to be 10,546.25. Okay. Then we define three zones based upon the data that we have so far. So zone 1 is from 0 on Q axis to the Q star EOQ, which is 612.37 gallons. Then zone 2 is from Q star to Q prime, which is from 612.37 gallons to 10546.35. And finally zone 3 from 10,546.3 to infinity, or Q prime to infinity. And then we look at the small q, which is 1000, and then we find out in which zone it lies, and we find that the Q star lies, small q, the threshold lies in zone 2, and hence according to our rule, or according to our model, as Q lies in zone 2, we should order exactly 1000 gallons, or the garage should order exactly 1000 gallons of oil. Okay, so this is a simple example. Now in the next video we move on to the next category, which is periodic review models. Okay, so see you in the next video.